Hey y'all, welcome to Miss Clark's chemistry class. I wanted to work a few dimensional analysis problems with you. Now I'm going to break this into a two-part tutorial. This first one is for beginners. If you don't have a clue to where to start, this is where you need to start. The next part 2 video is going to be just a little bit more complex. So if you're kind of feeling okay, then maybe you start there. Okay, let's get started. Okay, so remember, we've got to use dimensional analysis. That's the whole point. I don't care about converting units. I care about dimensional analysis. Now remember, dimensional analysis uses conversion factors. A conversion factor is a statement where both items on either side of the equal sign are equal to each other. For example, we could have 4 quarters is equal to $1. Or we could say that 60 minutes is equal to 1 hour. These are conversion factors where the thing on the left side of the equal sign is equal to the thing on the right of the equal sign, even though the number is different and the unit is different. We're going to use conversion factors and they're going to look like fractions. Okay, so let me erase these and let's do our problem. Now, every single time you get started on a problem, you're going to start the exact same way. We're going to write our given down first, 47.3 kilometers. You know what? I never even read the problem. How many millimeters are in 47.3 kilometers? 47.3 kilometers, that's our given. Now, we are not only just going to write our given, we're going to go ahead and set up our cross, and whatever unit is on top, we're going to bring that down. You know, that's the secret to dimensional analysis. If you always keep your units diagonal when you're placing your conversion factors in a row, you will always have the problem set up correctly and you will get the right answer. Okay, so we have written given, we have set up our cross, we have put our unit down at the bottom. Now we've got to start thinking about conversion factors. So here is my list of conversion factors. Now let's see what we have. We know we're starting with kilometers. So if I look over here in my conversion factors and I'm looking for kilometers, and here's kilometer right here. Let me make a little mark right there. Now kilometers, that's going to meters, kilometers to meters, and I need to go from kilometers to millimeters. So if I'm at meters, now I need to find something about meters and millimeters, hopefully. And I look over here, I've got 1 meter is equal to 1,000 millimeters. This is going to be my other conversion factor. I need to use both of these. So let's go back to our problem. So we have 47.3 kilometers. I set my cross up, bring kilometers down. Now we're going to add conversion factors until we get the unit we want on top. We need millimeters on top. So we're going to keep adding conversion factors until millimeters is on top. Now that first conversion factor stated that 1 kilometer equals 1,000 meters. I need to put that in a fraction where kilometers is on bottom. I know kilometers needs to go on bottom because I've already put it there. So 1 kilometer equals 1,000 meters. I'm looking for millimeters. Meters is on top. That's one clue that I'm not done. Plus, we had already looked at the conversion factors and knew that we were going to use 2 conversion factors. So kilometers cancel out. Every single time you add a conversion factor to our problem, before you add the conversion factor, whatever unit is on top, bring it on bottom. That's what's always going to keep your conversion factors diagonal. Now remember that other conversion factor said 1 meter equals 1,000 millimeters. So 1 meter equals 1,000 millimeters. My meters cancel. I have millimeters on top. That's what I'm looking for. I'm ready to put this in the calculator. All of these numbers are on top. Top, top, top. Only ones are on bottom. So we're just going to multiply. So I'm going to put 47.3 in my calculator times 1,000 times 1,000. Now I am still wanting that as 3 sig figs, 1, 2, 3. And I'm getting 473. Let's see, how many zeros is that? 1, 2, 3, 4, 5. And that would be in millimeters. Okay, let's work another problem. The world record for the 800-meter run is 1.68 minutes. How long is this in nanoseconds? So again, the first thing we always want to do is write our given, 1.68 minutes, our cross, and bring your unit down. Now we need to start thinking about conversion factors. Now, I could look back at that chart of conversion factors. The thing is I know about time. I know that 1 minute equals 60 seconds. And I've already put minutes on bottom, so I know this conversion factor is going to be oriented with 1 minute on bottom, 60 seconds on top. Now I'm looking for nanoseconds, and I'm only to seconds, so that tells me I need another conversion factor. My meters are going to cancel out. Before I add this conversion factor, I'm going to put seconds on bottom. So 1 second is equal to 1 times 10 to the 9 nanoseconds. So let's put that onto our problem. I just realized I changed colors. Let me get back. So 1 second is equal to 1 times 10 to the 9 nanoseconds. Seconds cancels, we're getting nanoseconds. Now we need to put this into the calculator. Okay, let me see if I can manage this and show you me putting this in the calculator. Okay, now all these numbers are on top, so I'm going to type in 1.68 on top, so times 60. Now this is the part that I really wanted to show you. We're going to use the exponent key. We are not going to use times 10, and we're not going to use a little up caret. See that capital E, right above the 7? It's not focusing, is it? We're wanting that, so I'm going to push second, that button, and look, it's going to give me an E, 1 E, and then I'm going to push 9 equals. Our answer is 1.008 times 10 to the 11th. Okay, so we are getting 1.008 times 10 to the 11. Now, wait a minute, sig figs. 1, 2, 3, 1, 2, 3, 4. That's not a good answer. 1.01 times 10 to the 11 nanoseconds. Okay, let's work one more problem. Okay, let's work this problem. It's the tiniest a bit more complex. Convert 3.8 kilometers per second to miles per year. Now, the only reason why I'm saying it's more complex is because we're going to convert 2 units at one time. We need to take kilometers to miles, and we need to take years to seconds. You can do this all at the same time. Again, we're always going to start with writing our given, 3.8 kilometers, but this time when I set my cross up, I'm going to put kilometers. See how kilometers is on top and seconds are on bottom? So I'm going to put kilometers on top and seconds on bottom. I'm going to do kilometers first because I am top to bottom, left to right kind of girl. So I like to do the top first. Okay, so now that we've got our given written down, we need to think about some conversion factors. Let's look at those. 1 mile equals 1.61 kilometers. Okay, now kilometers is on top. We should have already put kilometers on bottom. And I'm going to put 1.61 with that kilometers, and that equals to 1 mile. Okay, so we have mile on top, and we were looking for miles. So let me cancel out my kilometers. That's pretty good. We're halfway there. Now we need to get our seconds. Our seconds, we need to change that to years. Now, this is a little bit different because seconds is on bottom. So to cancel seconds out, we've got to put seconds on top. Because remember, it's all about keeping things diagonal. So seconds on top, we normally take seconds to minutes, and we know that 1 minute is equal to 60 seconds. Our seconds cancel. We've got to keep going because we're going all the way to year. And then now, my minutes is on bottom, but that's what we're trying to get rid of, so I'm going to put it on top. Got to keep it diagonal. I'm going to put hours. 1 hour, 60 minutes. My minutes cancel. I'm trying to get to year. I know that hours has to go up top to keep them diagonal. I'm going to take it to day. 1 day, 24 hours. Hours cancels. Now I'm finally to the point to where I can say, put my day up top, put my year on bottom. 1 year, 365 days, 365.25 if you want to get super technical. I don't, so I don't care. Now, I have mile on top of year. I am done. I'm ready to put this in the calculator. You could put this in the calculator a couple of different ways. You could multiply across the top, write that number, multiply across the bottom. Well, that's the only number on bottom. 3.8 divided by 1.61 because it's on bottom, multiplying by 60 because it's on top, multiplying by 60 again because another 60 is on top, multiplying by 24 because it's on top, and lastly multiplying by 365 because it is on top. And you know, we went from kilometers per second, we went to miles to years for years. So this is how many miles in a year. We expected a really big number. But the thing is we only want 2 sig figs. So let me show you what I'm getting in the calculator. 311377192.5. That was in the calculator. But I only need 2 sig figs. So that's 1 and 2. My number's going to stop right there. I'm going to look one past. This 1 tells me to leave this other 1 alone. So I'm going to do 31. Now, I can't leave all these numbers blank because if I owed you this much money and I tried to give you this much money, we're going to have problems. So we need placeholders. We're going to need 1, 2, 3, 4, 5, 6, 7 zeros. And that would be in miles per year. Okay, well, I hope that helped you get started with dimensional analysis. I have another video with some more complex problems, so when you feel good with this one, jump to that one. Okay, y'all, until next time, bye, y'all.